Hello. How is your morning going? We're at day 8 of Advent of Code. And I thought I'd start with printing out our message from the elves. So let's see what we have here. Oh, no, I need to get this whole paper out. So wasteful. But fortunately, I do have a lot of paper to spare. Okay. So that is it. What have we got today? Where's my pen? My pen has been traveling again. Hold on a second. Okay, here it is. Day 8. Haunted Wasteland. You're still riding a camel across Desert Island when you spot a sandstorm quickly approaching. When you turn to warn the elf, she disappears before your eyes. Ooh. Spooky. To be fair, she had just finished warning you about ghosts a few minutes ago. One of the camel's pouches is labeled maps. Sure enough, it's full of documents, your puzzle input, about how to navigate the desert. At least, you're pretty sure that's what they are. Well, turns out in part 2 that they're not gonna be that. Or we've been misreading them, or something like that. One of the documents contains a list of left-right instructions, and the rest of the document seems to describe some kind of network of labeled nodes. Okay. It seems like you're meant to use the left-right instructions. We're probably not, but anyways. To navigate the network. Perhaps if you have the camel follow the same instructions, you can escape the haunted wasteland. After examining the maps for a bit, 2 nodes stick out. AAA and ZZZ. You feel like AAA is where you're now. And you have to follow the left-right instruction until you reach ZZZ. The format defines each node of the network individually. For example, okay, so this one reads right, left. Each node of the network individually, for example, right, left, and this is AAA, and here's ZZZ. Starting with AAA, you need to look up the next element based on the next left-right instruction in your input. In this example, start with AAA and go right R by choosing the right element of A, C. Okay. Then left means to choose the left element of Z. Z. What did it print over here? Oh, it's got some kind of printing tool. Okay. So left element of C, Z. By following the left-right instructions, you read Z in 2 steps. Z in 2 steps. Okay. Oh, okay, so this is gonna be a Dijkstra coming up. In part B, I think. Of course, you might not find Z right away. If you run out of left-right instructions, repeat the whole sequence of instructions as necessary. right, left, and so on. For example, here's a situation that takes 6 steps to reach Z. Left, left, right. Wait, what? For example, here's a situation that takes 6 steps to reach Z. Left, left, right. Study A, follow the left, right instructions. How many steps are required to reach Z? Okay, I get that, but how is that example an example of... So right, left, 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 right. Okay, whatever. Yeah. Okay, so I'm pretty sure in this first part, we need to follow these instructions to find how many steps do we take to reach Z, and in the second part we need to run Dijkstra to find the shortest path instead. That's my guess. Cool, okay. And I guess these nodes, there's gonna be way more than just 26 nodes for the alphabet. So these are gonna be like A, B, C, C, D, F, or something. Oh, let's see what the puzzle input says. So going back here. So save the input, for example. Save to floppy disk 2023.example8a.txt. Okay. And then the other examples of this. Save 9 23.example8b.txt. And then save the input 2023.input8. Okay, perfect. Yeah, those are like three letter things. Let's see what this looks like. Okay, so we have a really long list of instructions. And then we have a ton of nodes. Okay. How many nodes? Page full. So 300 About 75. No, 750, yeah, 750 of those. Hmm. So if I have what is 26 to the power of 3? That's more than 8,000. And less than 27,000. So I'm thinking I could theoretically build a static array out of those. Oh no, I couldn't. Because I would need multiple bytes per record. Okay, I'm building a hash table. Yeah, that's what I'm doing. Okay. So can I get back? Yeah. It's weird how the restore key doesn't always work. I don't know what's going on with that. Okay. Include libc data int main. File f equals f open 2023 example 8a txt from 9 read. Okay. And then instructions. What do we have? Maybe we have, can we fit it in 256 bytes? F gets read the instructions. No. Semicolon here. That was weird. Okay. Save to device 9, 2023.9a. Oh, not 9.8 and the TDP. Okay. So now if I run. Oh, this is no, I want to run on the actual input. Okay, so the example is more than 256 lines. Oh wait, is it? No, I'm confused. No, it does fit. Why? Wait, what? No, it seems like there's something fishy going on again. Yeah, it didn't fit, but this one fits. Okay. But why did I need this mem set? Surely they should just add a new line in. Ooh, okay. I think I have a bug again in my implementation of fgets. Because they should write a... Like there's supposed to be an empty line after this first line. So this is supposed to print a empty line in here. That's a bit concerning. Let's see if I do that again. What do I get then? Oh wait, what's this? What's this bigger than that? No. Yeah, it does fit there. Yeah, there's something really fishy going on. Some kind of a bug. Okay, let's see. Okay. Okay, I need to double check this. Yeah, I think my fgets is tripping up when it's reading a new line. But in any case, I'm not gonna mind that because I am not going to use fgets to parse these later lines. So we get the instructions, and now while fscan f, I'm gonna scan the, so that's %s equals opening parents %s. Oh, I don't have. Yeah. So scanning is always greedy. So I cannot put in like a closing parents here because that's going to always be part of the string. So that's that's how I read the line. Star S up, source left right, source left right. Can I fit this in one line? Yeah, I can. Okay. Let's see if this works. Source left right. Perfect. Wait, no, wait, what? Why am I printing 4 of those? There's a lot of nodes. There's gonna be a lot of work for Dijkstra. Oh, and then on top of that I crash. Okay. What is going on? Okay. Well, let's make these a little bit bigger. I'm using example. So why do I keep printing these? That was interesting. Okay, not quite sure what that is about, but okay, now I'm parsing this. So, I need the hash table. And I need the node type, so let's do the node type first. So I have a struct node that is node left and node right. And I need to know what is finished, so let's do bool finish. So this is gonna have a finish equal true. Yeah. And then a hash table node and how many of these I can do. That's 5 bytes per node. So I should be able to do 5,000 of these. That will be 25 kilobytes. So let's do 4096. Yeah, nice 12 bits of memory usage. And oh, but I do need to store the character value here. Crap. Because I do need to identify. Yeah, if I'm doing linear probing in my hash table, I do need to identify these nodes. So A to Z is 5 bits, so I need 15 bits. So U16 name. So now this size is actually 7 bytes. Well, that's still 28 kilobytes, so that still fits. And there's gonna be a Jytra visited boolean as well, but that's gonna be 32 kilobytes. So even that should fit. Okay. So then I need a function that gets the name. So name const char s. Return S0 minus A shifted left 10 places. So I'm basically packing these into bits. Where's my OR? Here's my OR. So then this same thing. Packed 5 bits and then so like this. Yeah, that looks good. Oh. So now I'm packing the name of the node into a U16. Perfect. Okay. And now I can U16 source equals name s U16 left equals name left and U16 right equals name. So now I have these nodes and now I need to find them. In node star hash. What's my hash function? My hash function is gonna be... So I have 12 bits of index space, and I have a 16-bit thing to hash. So I'm short by 4 bits. So my hash is gonna be hash equals name so the 12 lower bits XOR'd. Ooh, I get to use the XOR. I draw a custom character for this XOR symbol because C64 font doesn't have this XOR. That's the up arrow on the keyboard. That was fun. Fun afternoon a couple of months back. And then so that's 12 bits. So then I can shift the rest right 12 bits. So that's my hash. Oh, but I really would like... Or does it matter? Should these upper bits hash into upper bits of this index space? Well, probably doesn't matter. Okay, and then while n hash dot name is not name. No. Hash name. Yeah, while n hash dot name. Yeah. So as long as so this is the linear probing part for the hash table. So as long as the name exists, or that there exists an item in this bucket, and okay, whatever. Oh god. I'm coughing so bad. Damn flu. Okay. So while there is a node in this bucket and it's not the thing that we're looking for, plus hash. Oh no. Hash equals hash plus 1 and 4 not 5. So this is the linear probing part. And then now I do return node. No, you return n. Okay, so here's our hash table. So now I can populate the hash table. So let's go. Node star n equals hash source. N what did I have? Name, finish, left and right. Name, finish, left and right. Node name equals source. Node finish is false because that's in the 0 section. Left, was it L? Yeah. L equals hash left, and node right equals hash right. Perfect. Okay, so that should hopefully work. And then we need to walk. Then we need to walk the... How am I on memory? 4 kilobytes. That's a lot. Okay. Then I have a current node equals hash hash name AAA. So we're at AAA in the beginning. Oh, and hash name ZZZ is a goal node. U16 steps equals 0. While we are not yet finished, const char I equals instructions. Oh, now I have this really nasty thing about fgets is that when you do fgets and it reads a line from a file, the returned line actually contains like ends in a new line. So I need to do here if instruction through length of instruction -1 is a new line. Then or actually no, I don't need to do this because I can just, oh, silly me. Yeah, I can, yeah, that is, I mean, that that is an effect, but I don't need to mind to that. So I is where we're currently at. If I is left, plus steps. So we make a step. If I equals left, or actually, if not I or I, so equals. So I'm gonna account for that new line here. I equals the instruction. So instructions wrapped around. If we're going to the left, so current equals current left. Else current equals current right. Plus I. Oh, let's put this one here. Yeah, this looks very good. Print F. How many steps we took? Are we doing an infinite loop? We took 2 steps. Oh, but yeah, that's the right answer for the naive part. Okay. Let me skip this printing. And this was supposed, so first one was that naive 2 part, and this was supposed to be 6 parts. Four steps. Ooh. Okay. I need to print where I am. So I need a function that maps this back. Where is it? Here. So C0 equals name shifted right by 10 plus A. C1 equals name shifted right by 5 and it by 31 plus A. And C2 equals name and it by 31 plus A. Return C. Okay, so now I should be able to debug what the heck is wrong with my instructions. What? I start at this is printing the same thing. What? That was weird. So why am I not getting this right? We go left from A. We get to a B. We go left from B, we get to an A. We go right from A, we get to a B. We go left from B, we get to an A. Sorry. So we start at A, we go left, we come to B. So then we again go left, we come to A, yep. And then we're at A, when we go to right, we get to a B. Well, and then what is going on? And then we get ZZZ. I thought I had this, but jeez. Let's do this again. Two. Yeah, let's do it like this. Oh, I get an empty thing. Oh, so the issue is with... Wait, is this a... Is this a regular new line? Yep. Oh, I see. This is again my pet ski thing. I should be converting these to pet ski. That was my day but one bug. Or was it day 3? Yeah, in pet ski... The \R is the new line, but here it is. Okay, so I can do this. Okay, 60. Yeah, I should have suspected that at the very beginning. Okay, so I still have a pet ski conversion bug. That's the 3rd time that is a bug in this. So it's pretty interesting. Okay. Six step. I'm curious. How did this thing work? Is it like this? Yeah, okay. So that's a nice one. Okay, so let's try on the actual input. If I'm lucky, this might yield something interesting. So while it's flashing the border, it's loading in the nodes. Hundred and 30 steps. Okay. 130 steps. Let's give that a go. So I'm gonna save this. And then go to Advent of Code. Oh, good morning, Python. Do you also have Amiga speed, by the way? I do have an Amiga 500. But yeah, I never had Amiga back in the day. But I did get some one like maybe 6 years ago or so. But I haven't done too much work on that. 130. Not the right answer. The answer is too low. Okay. can I get back? Okay. So why wouldn't this work? Let me add sanitation to this. I'm still a little bit skeptical about this. And what can I do to debug? Think about getting an Amiga 500 as well. There's a nice accelerator card for individual computers that expands memory. Also has a higher frequency. Back in the day. Yeah. Oh, individual computers also does an accelerator for Amigas. That is cool. So I have an ICOM accelerator, or not accelerator, but like a cartridge here for RAM expansion on this one. What can I have wrong here? So this is the tricky thing, because I would need to do quite long, potentially long debug prints here, which really would require a PC, but what can I get by without? Let me do previous equals current. Yeah, after Commodore 64, I also moved over to the PC. So we had this exact Commodore 64 was the very first PC or a computer, and then after that we had a 386. So that was the path that we had. So let me do. Is it S? Or actually, I do need to do this and S. So do this. Let's see what this means. Well, the C64 using is the one you had back then. Yeah. My mom saved this. She put it in the attic or like upstairs storage. It was there all those years, and then maybe some 10 years ago, 8 years ago, something like that. I just found it and it was working. The Commodore key was broken. I remember we were running like, you know, circles around the Commodore like when we were kids, and somebody kicked the corner of this computer and they kicked the Commodore key and that flew somewhere. So that's the only thing that was basically broken, so I got a replacement for that. BCZZ. Okay, so everything checks out here. I mean, like, reads fairly good here in this input. Yeah. Why? Well, I know pretty much that was not the issue. Oh, but okay, one bug at least. I don't treat so my name function maps AAA over to a valid name. So these are actually all AAAs at the start. So that's one potential issue. How do I fix that? What is the Petsky character before A? Do I have the Petsky character before A? Let's take a peek. So I have mapping the Commodore 64. So if I look here, ASCII code 311. Could I use, okay, so here, so that's an add character. Yeah, what I can do is, I mean, well, I could do just +1, I guess. Or putting the at. Well, so in this way, the initial node values, I won't map anything to that. Let's see if that changes anything. Oh, but my naming is all well. That's just for debug printing. My naming is gonna be all off, but. Okay, so this is now the 1 hour mark. So I've now been working on this for 1 hour. What is this? Okay, that probably wasn't right, so I did a mistake there. I got stuck. What is happening there? What's happening there? Let's try the example again. Do I get a... Okay, so this one still works. And example 8a. Yeah, that one also works. So why... We hash the source. Oh. So this should never happen. Actually, this... yeah. So that should never happen. Oh, could I overflow? Oh my god, is this again an integer overflow? Could this be an overflow issue? That would be such a classic if it was. Let's see what happens. Oh, but no, but I wasn't hunting an overflow right now. I was hunting a mismapping of the A. So actually, I'm hunting for a crash. Why does it go down that infinite loop? That was the bug. After I added those +1s. So all of this stuff... Oh, I can use Control to pause printing or slow down. That's interesting that it works here, like in my own programs as well. Oops! I am getting an oops. FKJ to FKJ. Why am I getting an oops here? Or this again at the end of this instruction. Jeez. Okay. Okay, so let me do this is not. Let's do this the super. Not L. And I is not right. That is such a weird thing to have. Like, what am I actually reading into these strings? Okay. Now let's see. I've fixed so many bugs on the fgets and fscanf implementations that I'm gonna feel so bad if I still have one in lingering in there. Okay. Yep, it's going down nodes left and right. Okay, for quite a while now. Okay, so if this is now going like thousands and thousands, this is gonna take quite a while. Where is this music from? This is part of the some of the demos. So this is a mega demo. I think the credits are gonna come up just in a couple of minutes from now. So this is a mega demo that people did. I think this was during the COVID quarantine year, like 21 Christmas, that people did this kind of like it was a joint work by several people from demo scene. Okay, so this is now taking such a long time, so I'm gonna pause this. I do need to remove these debug prints because they are slowing down the printing. Actually, I'm going to remove that as well because this is now guaranteed. Okay. Yeah, I have no idea what is in my strings. Yeah, these guys really know what they're doing. That's so so jaw-dropping. Something that I do wonder is like the code density that they generate, because this demo does come on 4 disks, and some of those demos, they probably pre-compute quite a, like this 3D balls thing. I'd be curious to know how much they pre-compute for these demos, because you could basically pre-compute like the whole video in there. But of course, well, that's not what they're doing. Like, definitely they're not doing that, but there's a lot of pre-computation that they can still employ. Where can I get these? These are all freely downloadable from CSDB. So there's a Commodore scene database. Some of these that I recorded, I went on CSDB and I put in a search word Christmas in there, and then took a bunch of these Christmas demos for showcase. So yeah, so here's the credits, and quite like this tune as well in the credits. That's pretty nice. Okay, so now this is calculating quite a while. Going through all of those nodes. So the answer is gonna be way more than 130, but yeah, we'll see how long this takes. This might be spinning for quite a bit. I remember last year when I was doing this challenge on the 386, that the 386 had pretty good track record in terms of performance. Like, it didn't really have long run times in most of the puzzles, but there was this one puzzle where you had to like, there was a double linked, like this kind of like clock dials, like linked list that went around in a ring, and you had to basically swap elements inside that linked list and then traverse like that pointer by pointer by pointer. And that took like like something like a couple of hours or something to basically spin through, because there was just so much of iteration that happened. So I think this year on the C64, yeah, that kind of looping is gonna kill the CPU performance overall. And I have no idea how long this would take. Might be that I have to just, if this doesn't finish in a reasonable time, I'll have to just run this on a PC and see, because right now I really have I really have no way of figuring out if I've got into an infinite loop. Or actually I would, but that would be quite involved to debug. But on a PC you can pretty much see instantaneously if you got to an infinite loop or if it's gonna finish. Yeah, here it's anybody's guess. Actually, what I think I'm going to do is I'm going to take a short break. I'll leave this thing on so it can go and calculate on the background. So so I'll have a short break and eat something, and I'll come back to this when this finishes. And I think on the side, while I have a break, I'll actually run this code on the PC to see whether this is gonna finish, and I just have to wait, or if this might be running in an infinite loop, because there's very little way to actually know this otherwise. So all right, so I'll catch you guys in some while. Hello, hello. All right, I am back, and I solved the issue, or I solved this puzzle on a PC and debugged what's going on. So, so this is not going to finish, not even on the PC. And the reason for this is that peculiarly, this hash table is too small. So what is happening is that this is basically turning into this kind of linear hashing scheme, which actually is a little bit surprising because there's only about 600 elements in the table. Or it could be that my hashing function is somehow bad. But yeah, I can't quite figure out what to do with the hashing function. So what I'm gonna do is instead, how much memory? Okay, I have, yeah, I have 1.5k of memory. So what I'm gonna do instead is I'm going to turn this hash table in, or sorry, turn this data structure into a binary tree. So here I'm going to have binary left and binary right. So that's a little bit unfortunate, but yeah, node binary root. I'll have to later on see if I can figure out how to so like search maybe if there's a better hash function. I tried increasing this a little bit, but I cannot make this 8k because that would be too much. So that's a bit unfortunate. But anyways, yeah, we're gonna have a binary table and then find in that binary table. So node star r equals binary root, while r, let's see. So hashing goes away. I'll try to analyze this hashing a little bit later, but so if, let's see, if r, what was it? It's name. If r name equals name, return r. Else if name is smaller than r name, if r bl, so if r has a bottom left child, r equals r bl, so we traverse to the bottom left child. Else we're going to allocate a new bottom left child. Else RBL is gonna be node star CLOG 1 size of node. Return RBL. Okay, now I'm gonna run out of memory pretty soon. Else if r bottom right, r equals r bottom right, else r bottom right equals node star. All of this stuff. Return r bottom right. Yeah, so if this thing already exists in the map, we return it. Otherwise, we check if we're supposed to go to the left subtree. Yeah, if node exists, traverse there. Otherwise, we allocate a new and insert. Okay, so this should be good. And now, okay, hash find. Oh, and of course, I can just do node goal equals find name zzz, and I don't need to have this finish boolean at all. And current equals to find, yeah. No finish boolean needed. And then while current is not the goal. And what is going on here? For oh. If not the root. B root equals to alloc one size of node. Okay. So save. Yeah, that was a shame with the hash map. Let's see how this approach works. Well, it works like an infinite loop. What's wrong? What's wrong? Find name left. Find name right. Do I get through this one? Oh. I don't get anywhere with the search. Okay. Search. Oh, This is all garbage. Wait, no. No. Did I? No. Oh. I'm not assigning tar BL equals name. I'm not assigning these names. Bottom right name equals name. And now I run out. Oh no. Was that my problem all the time? It might have been. But then... Yeah, I bet... I bet that was my mistake. So I got just a lot of... Oh. 9.23.88. Oh my god. So I wasn't naming the things. And that's why I got a lot of duplicates. So that must have been interesting. So I was creating a hash table and I was adding these, but I wasn't naming all the nodes that I was adding. So I would see that as a lot of duplicates going into the hash table. Maybe. Name. Yeah. See, the thing, I do assign the name here, which I don't have to do, but I didn't assign names for left and right. Oh, so bad, so bad. So let's run. Okay, 2 steps. And 6 steps in 8. That was quite something. So the right answer should be, or the answer that I got on PC was, I think, something like 15,000 or 18,000 or something like that. Oh, do I have the... No, I didn't have. Okay, good. 18113, yeah. So I'm confident about this answer. Where's my pen? My pen has traveled. Why does my pen travel always? Okay, here it goes. So, so this was too low. 18113. Okay. Way to botch up a hash table. So I need to revisit this hash table just to see if that would work. But let's first see what happens here. I mean, this binary tree is pretty fast. Like, as you saw, like the runtime was probably dominated by these prints. So that's not big of an issue. But let's see. 8. Answer 18113. Yeah. Okay. Yeah. Okay, so screwed up a hash table. And that was probably like an hour lost figuring that out. Okay, let's see what happens in part 2. So, need to print this key. And then let's go to the printer and shift key. Okay, so that was the instructions. So let's see. Paper advance. get all of that up here. And there's a tear line here. I don't know if you're supposed to use that, but if I use that, then I lose these tractor feeds, and I don't want to reposition or realign these. That's a kind of a pain. So let's cut from here. Oh, and I accidentally printed the first part instructions again, but that's not a big deal. Okay, so what do we have? Part 2. The sandstorm is upon you, and you aren't any closer to escaping the wasteland. You had the camel follow the instructions, but you barely left your starting position. It's going to take significantly more steps to escape. What if the map isn't for people? What if the map is for ghosts? Are ghosts even bound by the laws of space-time? Only one way to find out. After examining the maps a bit longer, your attention is drawn to a curious fact. The number of nodes with names ending in A is equal to the number ending in Z. Okay. If you were a ghost, you'd probably just start at every node that ends with A and follow all of the paths at the same time until they've all simultaneously end up at nodes that end with Z. For example, left, right, 1, 1A, 1, 1B, XXX, 1, 1B, okay? So there are A's in here, and then Z's here and here, okay? Here there are 2 starting nodes, 1, 1A and 2, 2A, because they both end with A. As you follow each left-right instruction, use that instruction to navigate away from both nodes you're currently on. Repeat this process until all of the nodes you're currently on end with a Z. If only some of the nodes you're on end with the Z, they act like any other node, and you continue normal. In this example, you would proceed as follows. Okay, I am at AA, 11A, 22A. Both walk left, 11B. Both walk right, 11Z. Okay. So in this example, you end up entirely on nodes that end in Z after 6 steps. Got it. All right. Now I'm thinking, is there some kind of magic modular thing we have to calculate here, or do I just get by with doing the naive thing? Let's try the naive thing. So save all of this. 2023.example8c.txt. Perfect, okay. Why? I don't know why it's so hard to get back, but that works, okay. Example 8c. So So if I wanted to have a boolean is and node or let's do that as a member. Bool is and return name name and with 31 equals z plus 1. So yeah, so the lowest bits, this is the end. Okay, and then do I need an is start? I think I do. Well, that can go in line. Okay, so let's save as 9 8b cpp. So I need a vector. And vector node star current nodes. If S2 equals A. So if this was a starting node, current push node. Okay, and I don't need this. I don't need this. And now this becomes an infinite loop. And for int I from 0, I smaller than current size plus I. Current I if we're going to the left, we loop this. I don't need that one. Current I equals current I left, else everybody goes to the right. Oh, what's the error? No viable overload. What? It doesn't complain about this, but it complains about this. That's peculiar. Is there some kind of fluke? Yeah, that was some kind of fluke, okay. And then for node n in current if n is at end, if not is at end equals false, break. Okay, this should do it, but how slow is this gonna be? Well, it hangs on the input. That's lovely. Yeah. What is wrong here? Oh, that was curious. How did that crash happen? Six. So that example should have been in 6 steps, so that should have finished really quickly. Okay, so let's see. For one, how many start nodes do we have? Oh, sometimes I'm really daft. Yeah. If and break. Jeez. Two start nodes. Oh, but break doesn't help. Break doesn't help. XXXX. We're stuck at XXX. Well, there is an XXX is a black hole state. So we're walking incorrectly. Okay. For I. Yeah, let's try this. What is it now complaining about? Okay, did I do something really weird? Oh, ran out of memory. Okay. Let's try this once more. Ooh. That is peculiar. Okay, so it does compile proper. So let's see what happens with this one. Ooh, okay. QAR. Okay, so I'm corrupting something real bad. What is happening here? What is happening here? QARRAR. I don't even have such node. Oh, this should be a minus, right? Yeah, that should be a minus. Two start nodes, and those are in the middle, so oh, that's because, wait, no. No. I do take this. What do I have here? Oh wait, that's because in this example I don't have just letters, I have, oh crap, I have numbers. Yeah, that's oh, sneaky. Okay, so in previous example they were all from A to Z, so I wrote that from that perspective. Now there's numbers 1. But that is only in this example, because the input is still the same. Well, that's... Wait, did the input have numbers? And I just didn't know about it. Oh, did the input have numbers? Oh, I don't do an... If I do have close here. Yeah, this one can go up to here. Did the input have numbers? No, it's just this. This second example has numbers. Yeah. Okay, so they did an example with numbers. So there's 1s and 2s. Oh, that's annoying. That's annoying. So, well, I'm gonna remap those over to characters. So there's what is there? A, B, C, and D. Yeah. Okay. So, example 8c. If s 0 fix s fix l fix r only fix r star s while s if if s greater than 0 and s smaller than 9, s is g plus s minus 0. Okay. What happens with this one? Program finished. Oh, because I just print that and return. HHAR to XXX. Okay, well that didn't go much better. Oh, that's because... No. No. Wait. So... That is peculiar. What am I doing here? So 0 would become G and 1 would become H. H-H-A-R. Where the heck does this R come from? Yeah, no, that wasn't. H-H-A-R. This shouldn't matter because that's already initialized. H-H-A-R. How can this print? To XXX. Oh, I'm so low. H. Jeez. Wait, why is it going left first? Else if line or I equals R else I'm getting crap in here again, am I? Unknown chart L. What? Huh. Unknown chart L. When did that become an L? Oh, what a what a great typo. Okay. And then I have this right here. And my end isn't triggering. Yeah, those are both at. So end is assigned to true here. If end break. So is end is false. So this is like minus a minus 1. Okay. Node or find name. Well, what was it? HHZ. Is end. Okay, so HHC is. What is name HHC? Two one one A. A is A is 10, which is 8 plus 2, so 0 1 0 1, and then we have a 1. Plus 16, 26. Wait. This needs to be 1 after all. What? 2 1 1 8. No. Oh. Minus a minus 1. Oh, so slow today. So slow. Yeah. So that would be z minus a. Ah. So slow. Okay. Does a small input have HHZ at all? So the example input has 1Z. That's why I'm doing this stupid fix thing to map those back to characters. Okay, 6 steps. So now that works on the example. So example you see here has 11A, 11B. So I map those to HH because of my, like, I condensed this character sets for this key. Okay, so I don't need this fixing now for the actual character set. And I can get rid of this stuff. Okay, so let's print how many start nodes we have. And then I don't need these things for now. Yeah, so that's good. Okay. But yeah, that's the question. Do I need to be somehow smart here? Oh. That's still the example. Input 8. In 8. So if there are a lot of start nodes, then there's a chance that you have to do some kind of quicker, like modular arithmetic scanning of where you're at in the input and how many steps to do. And six. Okay, only 6 start nodes. Well, I mean that is still quite a lot. So what would such a fast tracking function look like? I would have current position I would have the current position in the input. So input was 130 chars. So that would be a U8. And then I would have to have basically for each source node. That would be something like 600 elements. So that would be 10 bits. So that would tell me for each starting node, each position in the input, how many steps to take to get to the next finish. Steps to finish. But the trouble here is I don't have too much memory for this. So So can I build this table on demand so that hopefully it would be sparse? Yeah. Okay, so now I need this hash map again. So but this hash map can be opportunistic. Like if I lose computation, that's not so bad. Maybe. Oh, but then I also need to know Then I also need to know for all of the other. So if I have any node and any position in the input, when does that travel to the finish the next time? I still need to be able to have another input where I fast track. So given input and name, where is it after k steps? That is interesting. Okay, so I'll go ahead and prototype this kind of solution. But anyway, so I've been online for 3 hours now. Got the first part solved. I'm going to take a break now and have some lunch. And then I think what I'm gonna do is I'll look at solving this on the PC first, and then see if I can find a solution that basically condenses the memory usage in a way that I could ever port. So I think there's no point in trying to get this solved on this Commodore 64 because I have no idea how much memory I'm gonna need for this. So first get the solution on a PC and then see if I can port that to be running on the C64. Alright, so that is everything that I have on stream for today. Hope you have a fantastic weekend, and I'll see you later. Alright, bye.